Hi, I'm Stevie Fernandez.
And I'm Trish Whitmer. It's wonderful to see you back with us for this week's Explore Tulsa. Now, Stevie, did you watch the college championship games?
Yeah, I did, and was very impressed to find out that Nick Saban, only 5'6" tall, yay, short guys.
He's also the highest paid college coach, making just over $7 million a year.
That's $106,000 per inch. Just goes to show you that you get more value per inch with us short guys. How's the weather up there, Trish?
Yeah, there's only one way to find out for sure, and that's by taking a trip to the National Weather Service office in Tulsa and visit with Steve Piltz.
Well, right before I was born in 1957, the town was hit by an F4, so there was an F5 in 25 and then an F4 in 57, so it was pretty fresh when I was young, and you could just tell the community just really wanted to know what was going to happen next. And so I began to pay attention, and before long, people would start asking me, even when I was little, like, hey, what do you think it's going to do today? So I began to volunteer to go to the basement of City Hall during tornado watches and severe thunderstorm watches and help run the radios and gather reports from the field. So I had an interest there too, but eventually I went off to St. Louis, to the University of St. Louis, and got a degree in meteorology and joined the Weather Service. Some of it starts back in the history of the country with some of the more important airports, and I think Tulsa was seen as having kind of an important airport. It was an important area of the country, and so eventually a weather office evolved, and we've actually taken the office in the 90s and moved it from just a local service office to a forecast office. Well, just even on a blue sky day, there are things that we have to do. We're responsible for the aviation forecast for the airports in the area, so we're putting out cloud information and visibility and wind direction type forecasts for Tulsa and Riverside and McAllister and Fayetteville, Fort Smith, XNA Airport in Northwest Arkansas. So we have all that going on a daily basis. Plus we're making the general 7-day forecast that's out there too. The radar was at the airport, it was in a dark room, and someone called off the azimuth and the range in kilometers to where they thought the most important storm was. We took a grease pencil and with a map underneath plastic, we would plot that out and say, hey, that's over Sapulpa, we're going to need a warning for Creek in Tulsa County. And we would go from there. And that was back when the TV stations were already starting to have color Doppler, and so my wife came up and said, really, you're using a grease pencil while the guys on TV are showing me color radar? Basic definition of the rain chances and the snow chances go back to whether you're going to see something that you can measure or not. And so it doesn't, if you say there's a 100% chance of rain, that doesn't mean it's going to come a flood, that just means we should see measurable rainfall that day. But at the same time, we have forecasters who were born and raised in Oklahoma that work in this office and born and raised in the region and have been here for a long time, and so they know at times when to deviate from that computer information. But folks kind of know that once we start going above 40 and 50%, the chances of getting wet are starting to go up, and they know to be prepared. Well, Tulsa sits in a kind of a unique spot, as does a lot of the area here in the middle part of the country, where we have easy access to Arctic air in the winter. It can come right down the flat plains. We have easy access to moisture from the Gulf of Mexico. We also have dry air that comes in from the southwest, and so all these different air masses can meet here in the middle part of the country right around Tulsa and can cause the weather patterns to shift very quickly. But of course, in the busiest times are tornado nights and flood nights when we have warnings flying all over the place, and we'll fill this room with every seat being filled. The big blizzard from a couple years ago, we put out a blizzard warning while there was still sun dimly shining, and you just don't do that in Oklahoma. Snow is awful hard to forecast here, but that was a situation where we had a pretty good handle on it. And I remember my son, who was going to the University of Oklahoma then, he calls me and said, what did you people do? We've already closed school for tomorrow. And that was pretty exciting. And then several of us were trapped here for a couple of days because we just couldn't get out. And then of course we had severe weather. Even this last year, on the day of the Sand Springs tornado, the windows were blown out at the bottom floor of the office, and a lot of cars here lost windows because a tornado actually touched down near the office, and we experienced an 80 or 90 mile an hour wind gust. The big ice storms that have happened over the last 10 years or so, where Tulsa a lot of it was out of power for 3 to 4 days, and outlying areas out of power for a week or two. Those are things where if we have a handle on it, we feel like we really made an impact because we were able to tell folks a few days in advance. And for the ice storm, for example, we held a conference call with the state, and they were able to lift interstate restrictions for the big trucks before the storm hit. That way the power poles could start coming into Oklahoma actually before the ice storm occurred. Instead of having the ice storm down and then waiting for the restrictions to be lifted by the governor, all that happened kind of seamlessly, and we felt pretty good about that. It's pretty exciting just to be able to watch this evolution of things and kind of know now that if we come to a consensus here in the office that the forecasters really believe something's going to happen, I can pick up the phone and talk to some important people and things will start to happen, and that's pretty satisfying from both the scientific standpoint and the relationship standpoint.